Assalamu alaikum, dear students. Today, our topic is types of functions. As you are well aware about the definition of functions, I would like to recall once again. A function is a special type of relation in which every element of domain has an image in codomain. So here are different types of functions that we would like to highlight here today. The first type of function that is called one-one function. You see here, a function is said to be one-one or injective if the image of distinct elements of x means domain, under the given mapping f are distinct. That means different elements have different images. For example, we will take two elements from the domain, that's x1 and x2. If we have f of x1 is equal to f of x2 implies x1 is equal to x2, then this mapping will be called as one-one mapping or one-one function or injective function. Otherwise, it's called many-one function. So in one-one function, different elements of domain have different images in codomain. The next type of functions is called onto function, or it's also named as surjective function. So a surjective function is a mapping from domain to a codomain, given codomain, if every element of codomain is the image of some element of domain x under the given mapping f. Okay, so that means there exists a y in y codomain such that an element x in x is like this: f of x is equal to y. So these two types of functions are frequently used in exercises. And one more type of, before going to one more type of the functions, I would like to highlight here the remark regarding the onto mapping onto functions. That's like this: it's very easy to see whether a given function is onto or not. For that, what we have to do, we have to check whether the given codomain is engulfed by the range or not. That means whether given codomain is fully occupied by the range. That means whole codomain should be the range. That means f is equal to y. A range of f should be equal to y. So if the range is exhausted by, codomain is exhausted by the range of the given function, then that is called as the onto function. One more type of function that's called as a bijective function, or one-one onto function, one-one and onto. So a function is said to be a bijective function if it is both one-one and onto. That means above two definitions hold for some particular type of functions. Those types of functions are called bijective functions. So before going to the exercise, we would like to highlight here some functions, and we will check whether these are one-one, onto, or bijective functions. So we have here one function given in part number first, that's f1. You see in the domain we have 1, 2, 3, 4. In the codomain we have a, b, c, d, e, and f. Here the mapping is such that 1 is mapped to a, 2 is mapped to b, 3 is mapped to e, d, and 4 is mapped to c. You see that f is not mapped to any of the elements. F, the element of codomain, is not an element of the range. Now we will go to the definitions of one-one and onto functions. In one-one function, we should have different elements of domain. Different elements of domain should have different images in codomain. Yes, that's there. Different elements have different images. So it is one-one. Is it onto or not? No, because here is one, at least one element f. You see, one element f that is not an image of any of the elements of the domain x1 under mapping f1. so it is not onto. So we conclude that the function given in part number first, that's f1, it is 1 1, but it is not onto. Let's go to the next function, f2. You see here once again 1 2 3 4 in the domain, a b c d e f in the codomain, and we see that 1 is mapped to b, 2 is mapped to b. That means two different elements of domain are mapped to one single element of codomain. So that means different elements have same image, so it is not 1 1. So the opposite of 1 1 is many 1, so it's many 1 function. Is it onto? No, here's at least one element a. Even there are more elements, say E and F are also, they are not having any pre-image under this mapping F2. So we say that it is not onto. It is not 1 1. It is not onto. So neither 1 1 nor onto, but it is many 1 function. Next is F3 function. So once again in F3 we have 1 and 2 are mapped to A, so it's not 1 1. Is this onto? Here in the second set we have only a, b and c. There is no element which is not having any pre-image under this mapping f3, so it is onto function. So it is many one onto, so it's not a bijective function. You see function 4 f4, it is 1 is mapped to b, 2 is mapped to c, 3 is mapped to a, 4 is mapped to d. Every element of domain has an image in codomain, and every element of codomain has been exhausted with its pre-image under mapping f4. So you see that this mapping is 1 1 as well as onto. So this mapping is a bijective function. So I hope that you may now be well understood with these definitions. So it may now be clear that what is a one-on function, what's onto function, or what's one-one and onto. That means bijective function. So these four examples, I hope they will clear all these definitions. So after that, let's go to the exercise. And here you can see in the exercise, we have question number 1, exercise number 1.2. Show that the function f from r star to r star defined by f of x is equal to 1 by x is 1 1 and onto. We have to prove that this is 1 1 and onto, where r star is the set of non-zero real numbers. Then the question also says, is the result true if the domain r star is replaced by n, with codomain being the same as r star? So let's go to the solution of this. We have here the solution of this question, and I have solved it. So for 1 1, what we have to do, different elements of domain should have different images in codomain. So the function is defined by f of x is equal to 1 by x. We will we will take any two images, say f of x and f of y. We will check whether these two images have different pre-images or not. If they have different pre-images, then it is 1 1. If not, then it is not. Okay. So f of x is equal to f of y. F of x is defined as 1 by x. So similarly, f of y will be 1 by y, where this and x and y are non-zero, because the reason is that this r star is the set of non-zero real numbers. So taking the reciprocal, we can take it easily because they are non-zero. So x is equal to y. So f is 1 1. So the next point is, what about the surjectivity onto criteria? For that, we have to take a codomain element, and we have to check whether that codomain element is also an element of the range or not. For that, we will take one codomain element, say it's 1 by y, okay, and let's suppose that's a pre-image, that's an image of some pre-image x, where y is non-zero. So f of x, for this f of x, we will do one thing. F of x will be defined as 1 by x, but x is equal to 1 by y, so it is 1 by 1 by y, that's equal to y. This implies that for every codomain element, you see here, for every codomain element y, there is some element x in the given mapping, hence this function is 1 1 and on 2. So the question also says that if we replace the domain by n, the set of natural numbers, what happens to the this function? Will it be once again 1 1 and on 2? Let's check. So once again, we will go to the definition of the function. Say g of x is equal to 1 by x. We will take two images g1 and g2, g of x1 and g of x2. They are defined accordingly as 1 by x1 and 1 by x2. Since these are non-zero, so they will be x1 and x2. Yes, it's 1 1. What about the onto criteria? For onto, we will take any element of the codomain element, because we have in the codomain we have set of non-zero real numbers. We will take any of the set of any of the element from the set of non-zero elements. So this is for example, we will take 1.2 that belongs to this. Is 1 by 1.2 mapped to any of the element in the domain? No, because 1 by 1.2, if we will solve it, uh, we will we will see that 1 by 1.2 should have been mapped as per the function to 1.2, but 1.2 is not natural number, so we say that it is not onto, but it is 1 1. So I hope that you got it very well. uh, we have described these types of functions both ways, with the help of this arrow diagram and with the help of the algebraic notations, algebraic definitions. I hope that you got it very well. For if there is any confusion, you are welcome to ask questions either in the group or in the comments of the this video on YouTube. I will be more than happy to answer your queries. Thank you for joining the class. Thank you once again.